I'm just trying to piece it all together because I'm really fascinated by all. Like, the thing is like, because as we're talking, I'm imagining my friends and imagining different symptom pictures and trying to piece it all together. So for someone, when they go and do this organic acid test.
Yeah, this is what it looks like.
Yeah.
Yes.
They go and measure in their urine, that sort of stuff. But it's got to be related back to symptom picture, hey?
Absolutely.
You can't just go through, you can't just get this test done and then create a prescription based on that. You've got to ask them, what have you done?
Yeah. That's right. It's one of the things, like, all of these tests come back with a little blurb at the back, like this marker means this, you need to take this supplements. And I usually tell people, whether it's practitioners or people, throw that away. It doesn't mean anything. You're just going to end up taking a whole bunch of supplements because you have to look at this in terms of patterns to get an idea of. It gives you a three-dimensional picture of the person's biochemistry. So it's really about getting the full picture. And even, you wouldn't even treat every single marker that shows up normal on there. I found that if you get the key stuff there, you treat that, all of the other markers return to normal because it's just a way the biochemistry is shifted.
Yeah. So what do you see commonly? What's a common metabolic waste? Like
oxalic acid is very common.
We've done a podcast on it.
Yeah.
So the oxalic acid, so for people that have a problem with oxalates, it's a real nerve irritant, hey?
Nerve irritant. It also inhibits the pyruvate dehydrogenase enzyme, so it essentially downregulates the mitochondrial function as well. And it's a very, very strong chelator, the same as what EDTA is, which means it holds on to heavy metals.
Tetracetic acid, for those who don't know.
Yeah, so it holds on to heavy metals in the body.
Steve.
No, I just want to, because when I used to teach
and there is a quiz at the end of this podcast.
Yeah, people use acronyms. I always try and say, no, what's the word for that? With my students. And
I'm glad you know
because I used to fail them if they just said EDTA. I said, sorry, I don't know what an EDTA is. Yeah. And so I say, tell them what it is. But very interestingly, because you've got to remember that oxalates, if you had, like, what would happen if I drank a beautiful kale smoothie with almonds and blueberries in it? And because I want to be healthy, because I'm, one of the vegan activists that are around, and I have these beautiful kale smoothies that's loaded with oxalates, about a gram of it, considering our average intake's about 100 milligrams, 1/10 of that. Yeah. So that would drive up my oxalic acid dramatically, yet I think I'm doing something super duper healthy.
Right. Yeah, the green smoothie fad, so it's, and again, I'm nothing against it, it's all about the ratios. If you use a ton of spinach, if you use like a ton of spinach and things like that. Kale, on the other hand, kale contains sulfur, and sulfur somehow mitigates the oxalate absorption. So kale is not as detrimental as spinach. But the big thing is more that we've lost our microbiome diversity because there is your Oxalobacter formigenes, I think, is a bacteria that degrades it. So now we've had triple antibiotic treatments for H. pylori and who knows what else.
Helicobacter pylori.
Helicobacter pylori. And so now we don't have the gut bacteria that usually would break it down, which is why I think we're seeing more and more of that stuff in today's modern society.
So for those people out there going, they're talking about oxalic acid, blah, blah, blah. Hey, if you're any one of those people that has tried to get really healthy and fix up your diet and then everything's gone to shit, that's possibly you.
That's right.
Because what happens is that the healthy food, so we're talking about sweet potatoes, spinach, almonds.
Almond flour, the whole paleo diet.
Yeah, all those almond meals, all these nut meals. So if you try to go really healthy and incorporate all these foods into your diet, and then all of a sudden everything starts to hurt, everything starts to ache, your guts go weird, your waterworks go weird, your brain goes a little bit weird, then you probably get told you're going through a healing crisis by other naturopaths. Yeah. But what you've got to realise is, so with this oxalic acid, it creates pain.
Yes.
In particular, a lot of joint pain.
Yeah.
It creates crystals. Very similar. We talked about uric acid before. Oxalic acid crystals very similar. So, and what actually happens is these oxalates are found in all those good healthy foods. Okay. So why are they still good healthy foods? Normally because we have a diverse microbiome, we have strains of bugs that will actually deplete the oxalates. So when you're eating all these oxalates, only 10% of it should be absorbed into your body. Yeah. Most of it should be going straight through. Yeah. But if you've had your helicopter, your antibiotics for your helicopter and your pylori, and then you've had that and it's ruined your diversity, and with the antibiotics has allowed things like candida and clostridium to grow. Those things generate oxalates, don't they?
Right.
So what happens is you go from eating a good healthy diet where your body's taking in the great nutrients, all the low GI carbs or whatever that's coming on fibre, all that great stuff coming out of those great foods, you've lost your microbiome that would normally deplete the oxalates, and you've replaced it with candidas and clostridiums that actually make it. So all of a sudden, instead of 10% of your dietary load of oxalates getting into your body, you might have 150% of your dietary load. So all of a sudden, it's a massive switch. Now, these oxalates go into our body. The way we eliminate it, oxalates do go through sweat, don't they? We can sweat out oxalates.
Not as far as I'm aware,
but
no.
you urinate them out. So if you get too many of them, the most common cause of kidney stones is oxalic.
That's right.
Exactly, and that's also where vitamin C is bad for kidney stones because it increases that pathway too. Isn't it?
If it's too much,
So, and this is a funny thing. And sometimes people think I'm an idiot when my prescriptions, because sometimes with the oxalate people, I used to send them into a pharmacy because I didn't have this shit in my dispensary. And I used to send them into a pharmacy. Get the cheapest, shittiest calcium you can find. One that doesn't get absorbed. Go buy bloody calcium carbonate or something like that. A shitty one, and have that before your meals. So that way the calcium would bind to the oxalates in the guts, because the calcium oxalate crystal is quite large and it doesn't get absorbed, so you can poo it out.
Yeah.
And then I tell them to use a good quality magnesium, like a magnesium citrate, that's going to get absorbed through your body. So the magnesium is available to bind the oxalates, so you can wee it out, because the magnesium oxalate crystals look like tiny little envelopes. They look like envelope. Oh, you got to see them. They look just like an envelope. You know your little email signature?
Yeah,
your little email symbol. It looks exactly like that.
Oh, wow.
It's freaky. But the magnesium ones make these tiny crystals that are small enough to wee out. So I do these weird, and these people go, "Oh, you don't want that shit calcium. What sort of a naturopath have you got?" You know, and then they go and sell them some gourmet stuff. And no, I wanted the shit.
Because you don't want the calcium to be absorbed. You just want it to stay.
That's
in
why
the
the
gut.
Dolomite used to be so good for pain and emotion. Remember the old school naturopath? Oh, we'll give everyone Dolomite, which is just calcium magnesium carbonate or something. Like that.
Loved it. Loved the old days.
That oxalic acid's really interesting, because when you have a look at the link from everything we've said, again, it goes back to the candidas, it goes back to the clostridium.
Yes. Yep.
Oxalic acid, because it's a nerve irritant, has anyone seen any data linking oxalic acid with autisms and that as well? Wonder if that's one of those.
ADHD
I think
it
there
is.
is a paper on it.
Yeah, ADHD it does.
Yeah, because I know for a fact that when we go through and eradicate a lot of these bugs and that sort of stuff, that we get a much better symptom picture from it.
Because oxalic acid can store anywhere in the body. Now, we think about it as just kidney stones.
Yeah.
It's like, no, it can sit in the tissues, the muscles, the thyroid. They found even the heart. You can get calcium, oxalate crystals in the heart.
Very much so.
Yeah. And even in joints and that, it contributes to a lot of pain. And
well, if you look at it under a microscope, because I used to do a lot of live blood microscopy, is they look like little shards of glass.
Remember that?
So when you mobilize them, also when you start to get rid of them, it's painful.
And the fascia, that all just glue up all through that fascia.
So it's very uncomfortable.
Yeah.
You got to remember
and then dehydration would make it worse, wouldn't it?
Yes, yeah.
And the human body should be able to deal with these acids. It's just that some people, they can't because of the microbiome or the genes, or same thing really.
Or bile dysregulation.
Yeah, exactly.
Oh, yeah. And how's the bile fit in there as well? By regulating the microbiome still, or is there another?
That's one role, but there is a more direct role. Like if you have, for instance, let's say you do have a fatty meal with oxalates in it. So let's say an omelette with spinach or something like that, right? Yeah. If you are not producing enough bile, then the fats in the meal will actually bind to the calcium in the meal and create what we call calcium soaps. Yep. So that makes the calcium unavailable to bind to the oxalates and clear that out. Wow. So now oxalates become more absorbable, because it's like the fats and the calcium is occupying each other. So now you have more free-floating oxalates in the gut.
Yep.
And then so you have more absorption.
The process in the body is called saponification, if you want to Google it.
Yeah, that's right.
Yeah, well,
if you want
to. Because I remember a lot of data talking about calcium for fat loss. And it used to talk about that, the actual binding and the clearance of the fats through the calcium. If you have lots of calcium in your meals, I always use dairy as an example because apparently we get abundance of calcium from dairy.
Apparently, yes.
Most of it's shitty stuff floating around the guts, which actually works on that ability to bind to the fats and help that clear. But if you've got an oxalate issues, that would make it worse.
Yeah, that's why they first hypothesised cheese being very good for fat loss, but they figured out it was the conjugated linoleic acid in the cheese that helped with fat loss.
Oh, there you go.
They thought it was calcium, and then they did a placebo trial with calcium and cheese, and the cheese worked. and even though they had matched the calories, but it was because of the conjugated linoleic acid, the C911 form.
That's cool. Which only would come from the grass-fed cows anyway, wouldn't
That's
it?
right.
Not the grain-fed.
The old grass-fed cows.
Oh, that's cool, man. So
so
when you run through these organic acids, so just to summarise, so these organic acids we're talking about, some are waste products, some are fuels. They've all got a purpose.
That's right.
But we were talking about the energy production pathways in every cell of our body.
Yeah.
And then now also there's 10 times as many cells of foreign organisms living in our guts that all have these mitochondria. And not only are they producing these wastes, but they're supposed to be involved in the metabolism and removal of these wastes.
Yeah.
So a disrupted microbiome could be this is why there's so much new research now going into the effects of exercise on microbiome, but we need to have a lot more data coming out on what your microbiome profile.
Yeah.
And the problem is that we have a lot of them are qualitative tested, not quantitative, meaning that a lot of the microbiome testing are saying yes, it's there, or no, it's not, but they're not giving you the proper levels and that sort of stuff. So doing a proper stool analysis is a bit hard, hey, because the oat is better.
Yeah.
Because the stool analysis, I mean, weird people like myself might spend a bit of time looking at poo for curiosity, and I've even done. Remember, we used to do humour views, and I used to do the poo views.
Yes,
and put them on a slide just because I was curious.
Really?
Oh man, it was so cool to see the weird shit roaming around, literally
weird shit.
But no, the funniest thing is when you're looking at your poo, you actually do have little colonies of candida in it. And unless you're digging through it to make sure you get a little bit of this colour, a little bit of that, a little bit of these strands.
You're going to miss a lot of stuff.
Yeah.
And it's not just that. I mean, there's quality control issues with labs. I remember like we used to, I think we once sent the same sample to 4 different labs and got different reports from all of them. Right. And then you also, I know there was a recent study that showed that parasites, for instance, can self-destruct between being transported to the lab. So it's very hard to catch parasites on stool.
Yeah,
there's a new test method called R16S RNA testing, which tests the genome of the bugs. Now, it's a university test, but it may become more popular, and we'll have to keep an eye out for it, where it may become available to consumers.
Is it
research.
It's
quantitative and qualitative.
It's not the GI map, is it? Because the GI map...
No, it's not that. It's a bit more specific than that. And so it measures RNA levels and quality and quantitative.
Yeah, cool.
It's very
because I was nervous that the microbiome research was going to go down the same path as the genetic research, where people go through and measure it. Oh, you've got this bug, you're screwed, or you don't have that bug. We give you that bug, all your problems are solved.
Yeah.
Because that's where the genetic testing's gone.
Yes.
So I was really nervous the microbiome wasn't
and you know, we're all fans of Dr. Lynch and the Dirty Genes book. You know, it's very interesting read, but like, you know, if you've got a gene, unless it's what I consider a dirty gene is like the Huntington's Corella gene, which is on number 4, which means that if you've got that gene, you're going to get Huntington's. There's no ifs or buts about it. That's a gene that programs you to get a neurological disease because you can't make a protein in your brain. Guess what the protein's called? Huntington. Named it after Huntington's in 1872 fame. And it's funny because he named the disease and the protein after himself. Yeah. Loved it. 2 things. So that's a bad gene. But other genes like my HLA-B and all the other things are not necessarily bad. So you want to explain how...
That's confused me a bit. So I need you to explain
Dr. Lynch's book is, you know, when he talks about dirty genes, he's actually talking about environment and the expression of it.
Yes.
So it's not... That's actually exactly what he wanted to sort of clarify, that it's not about the mutation, it's about the environment. So when he says a dirty gene and how to clean your genes, it's like, well, if you've been exposed, you know, to toxins or what have you, it's going to make these genes dirty, and to clean it you have to change your diet, change your lifestyle and all of that. So it's more about the expression of the gene and how our environment and our diet and our lifestyle and stress affect it, because interestingly enough, like stress is a huge trigger for gene expression. We really underestimate the ability of how stress can affect both our mitochondrial function and our gene expression. We always think, oh, there has to be a toxin, you know, it has to be a heavy metal or something like that, and chronic stress exposure can have the same kind of an effect.
And what freaks us out about that is when you actually look at the definition of what a stress is, it's anything that makes a change in your body.
Yeah.
You can't afford to wait. It could be something different every time.
Yeah.
And they just... on top of each other. So you never get a break from stress. So
No.
Exactly. And you know, if you had my gene and you expose that to a Klebsiella pneumonia, you're screwed.
Yes, exactly. Because that's.
But if you're exposed to HIV, you're fine.
Yeah.
You know what I mean?
Yeah,
That's
wow.
the trigger.
Yeah.
So, and yet if you look up Klebsiella and you Google it now, you'll say, oh, it's fairly harmless and doesn't affect anyone, but it does affect people with
Absolutely.
HLA-B27.
It's very inflammatory. Like the people I
Very.
see with Klebsiella have a lot of pain and yeah.
Yeah, I mean, if you got this gene, you're absolutely screwed. You're in hospital.
Yep.
Thanks, you know, I know that very well. So you know, these silencing of genes and these sort of things and this genetic, I love the fact that he does talk about the environment.
Well, you can't cure. This is why I don't believe naturopaths can talk about cures anyway, because you can't cure the environment. We're looking at all this stuff. Yeah, it's a management. It's always management.
Yeah.
You know. So
And the fact is, it's just that our genes have not had time to, you know, we've always gone through evolution where our genes adapt to circumstances, but the Industrial Revolution came so quick. We did not have, our genes didn't have the time to evolve, which is why we have all of these chronic illnesses.
So a genetic polymorphism, and a polymorphism is not a synonym for defect. A lot of people, when that's a big word. What's polymorphism mean? Oh, it's just another word for defect. No, it's not. It's a variation of the gene. It's
a variation.
And if we go back to the MTHFR one that we talk about a fair bit because everyone else asks about it, that their benefit, we talked about its ability to do the strength, but also you can imagine a gene that would allow, when you're going through times of feast and famine and stress, a genetic polymorphism that allows your stress chemicals to be recycled and float around more, your estrogens to be recycled and float around more. During times feast and famine, that was beneficial. They survived.
That's
Plus
right.
makes them stronger.
Yeah.
So, you know, those people breed. Those bastards. No, those people breed. That's why they're everywhere.
They
and
are
the other
everywhere.
people that didn't have that polymorphism died off, didn't get a chance to reproduce, which is why there's less. You know what I mean? So we talk about this sympathetic nervous system dominance we see all the time, but these are all people that have inherited and acquired traits that have allowed them to survive in the past. But now we're exposed to so many weird little things that our body will manifest a stress response to. And even when we're asleep, those things don't disappear. So we just get kind of stuck. And now with this new understanding of the microbiome, knowing there's 10 times as many of those buggers, was it 150 times the amount of genetic materials or
I think
something
so,
something stupid like that. And their genetic material can adapt within a day through their reproduction. So
it's great. So you know, we talk about certain genes that are bad for today but great for when we're evolving. One of them is the Thrifty Gene, of course, and we're all probably familiar with that, which means that, you know, like an Aboriginal Indigenous person or Inuit Indians or any of those guys, they had more of a Thrifty Gene, which means they could starve for longer and still survive. So in other words, if you give them the same amount of calories as a Caucasian, then they will become obese and heart disease related.
Before
pre-industrial.
Solomon Islands and
all those
big islands.
The Tonans.
They got that
Thrifty
gene.
Which is
that's
great.
associated with is that an insulin sensitivity?
Yeah, absolutely
gene
it
or
is.
something like that. It's linked in with more IGF or something?
Yeah, IGF-1. And so basically, if you've got that gene and you're starving in the bush from time to time, great. But if you're in Western society with 3 meals a day, you are screwed. And you have a much more high chance of diabetes, heart disease, cancers, everything. Because IGF-1
go back and
drives
ask
cancers.
your mum what your birth weight was too, because they found a massive link with that particular gene for the lowest birth weight babies become the most obese adults. And they said, so what actually happens is the lower birth weight activates this overcompensatory feeding by the mums and that sort of stuff. So they go through and lots of breasts, lots of bottle. They measure, you're already below weight. If you drop off any weight in the early days, you know, we always talk about that 10% weight loss, and then we got to do something. You know, so these people are like, man, so what happens is they overfeed, they overdo things that activates the Thrifty gene, the small baby grows, and then they've activated a pathway where they're predisposed to obesity. That's an interesting link too, and that comes from prenatal and early life events that you actually activate a gene back then. I have no idea with that one if you can switch the bloody thing back off, but you become a management issue in those instances where we got to watch. You have
to dephosphorylate the kinase enzymes, which is a tricky way of doing it. You have to do.
Sounds tricky, Steve.
Oh, it is. It's a process where they give them lots of chromium 3 and all these sorts of thiazidic acid or lipoic acid, all these sorts of things they've done in trials that have actually sort of semi-helped it. Basically anything to help sensitise insulin.
Yeah.
So it's very interesting.
That's cool, man.
Yeah, it's pretty cool. But you've talked about how genes evolved, and if we really did have a bad gene, you were born with a bad gene, you would just die.
Yeah,
that's right.
So what are these bad
mitochondrial genes, for instance? The whole, because mitochondrial genes is a whole other thing.
They're genes inside they're different to the nucleus genes. They're genes inside the cell. Sorry.
That's right, and that's those babies would usually not survive for very long, and they would just
definitely not reproduce then.
No.
So
no, and that's nature's way of eliminating things that should not be carried over.
Yeah, but that's what you're saying before. Excuse me, our environment's changed so fast, so quickly. We haven't had a chance to evolve or adapt to these sort of systems. So what we're finding is the people that a couple of generations ago had a genetic polymorphism or a genetic structure that allowed them to benefit, all of a sudden we hit this era where you're better off having a nervous system or a genetic profile where you do not react to stress at all. Where in the past, that would have been the worst possible thing. Now it's going to take us a long time to evolve to the people that can sit inside a room with electromagnetic radiations and pollutants and eating crap and all that sort of stuff with not manifesting a stress response from that.
Yeah.
Because the Homo habilis was the great stressor, and that's what made him or her survive through that particular area. Because if they didn't stress to something, they would be killed.
That's right. Back they had to run away from the lion or whatever.
300,000 years ago, you were killed by lots of stuff, whether it be disease or a snake or a spider, and if you didn't stress to that, you wouldn't survive it. And that's what the Homo habilis species were the great stressors. And we still have some of their genetic material in Homo erectus and all that sort of stuff. So we really are, and Homo sapiens, which is what we are. And we do have some Neanderthal genes. Did you know that? I found that out the other day on the radio. I went, wow, because they're a species that are humans that died out.
I've seen a few of the guys. I've seen a few of them.
We were talking about
Neanderthal gene. Look at her Neanderthal gene.
We talk about some of the footballers and their reactions and some of their genes. But of course, they're having a lot of Neanderthal genes made you a very powerful hunter. They have very short arms, very powerful. So that would be beneficial for survival back then.
Giant foreheads, really good.
Yeah. But they were shit at surviving the cold. So the Ice Age, that's what killed them, the Ice Age.
Oh, that'll do it.
Yeah. So therefore, but if you're an islander with more Neanderthal genes, you would be, where you needed the strength, say you were a footballer, and you had better strength and you could tolerate heat more, what a great advantage.
Yeah, bloody oath.
Yeah.
But what if you were, surviving in an Ice Age, came down and engulfed half the world in snow, you die off. That's what happened to them.
I'm just sitting here, my brain's just flying now because I'm just thinking, I think not only have I worked out a lot of the problems with a lot of my friends and that sort of stuff because they're messed up. No, I've worked out a lot of this sort of stuff. I've worked out a lot of things about myself, but I've also think I've worked out how to fix the Australian rugby union team.
Oh my goodness!
We need to get into a little bit of that Neanderthal gene back into it. We've been focusing on the Thrifty Gene for too long.
Exactly. Oh, a Neanderthal would be a great front rower.
Yeah.
I mean, very powerful animals that are humans that are
really good in rugby because their knuckles drag on the ground. Just easily rake that ball back. I'd take the Neanderthal genes. They still had the same intelligence, so they still had the same amount of brain capacity, about 440 I still
cc.
struggle to start a fire by myself.
Yeah, exactly. But we're in Queensland now, for those who know, and that's semi-tropical area, so it'd be great for the heat. Great Neanderthal genes. So, have you got any of your favourite genes that you want to talk about that you think are interesting or interest to you?
Not my personal genes, right? Because
I've never
had my genes tested.
No, good. Me neither. Good. Did you manage to get life insurance because of it?
Well,
I'm positive it's a big.
It is.
It's a big thing. We're going to get your data. We're going to ship it out, sell it out to the insurance guys.
Especially with the overseas companies. I mean, that's pretty much happening.
Well, absolutely. Yeah. And if you had your genes tested for, say, the BRCA gene, which is a breast cancer gene.
Is that the Angelina Jolie one?
That's the Angelina Jolie.
Yeah. So, let's just quickly so you had tell us about your thoughts of that.
Yeah.
If she's positive to this gene or tested for this gene to be positive, that there's a predisposition.
Right. So maybe a bit controversial, but it's all about the expression. Just because you have a gene doesn't mean you're going to get a disease, which is why using it for insurance purposes or health fund purposes would be worse. It would be stupid. I don't see the point.
Because like you're saying before, people can manifest the expression of a bad gene without actually having the genetic testing confirming it's possible.
There's tons of people who have obesity genes and diabetes genes, and they're skinny and they're as healthy as anything because they live a healthy lifestyle. So you can't put those kinds of marks on genes. I mean, I very rarely have ever seen anyone's genetic polymorphisms match their health
outcomes.
issues.
That's a great answer.
So, you know, I can understand why some women would do it because they're fearful, and maybe that's also fear that gets created by the medical profession. But at the end of the day, it still has to be expressed somehow.
Yeah.
Now, again, stress can make things express, or unhealthy diets, you know, anything like that. But
well, absolutely. And we know a hallmark of, say, we're talking about quickly cancer, is that if you have a hypomethylation of the suppressor oncogene
yes.
and a hypermethylation of the ones that, the hypermethylation of the suppressor genes and a hypomethylation of the oncogenes, then that's a problem. That's a hallmark of cancer.
Yes.
You said in most cancers.
Yes.
So what you're saying is if you lack the nutrients and the ability to do the methylation processes properly, you can be predisposed to cancer because of a build-up of waste and all these other bits and pieces.
Typically,
but if you've got too much, if you drive methylation too fast, methylation's also involved in DNA replication and making new cells, which is why a lot of the anti-cancer drugs and autoimmune drugs block that.
Yeah,
right.
But it's like with cancer, though, it does start off as a hypomethylation. And then eventually when the tumor is there, then you get the hypomethylation in the normal tissues, but the hypermethylation in the cancer tissues.
Yeah, right.
So,
and it does that by itself then, wouldn't it? It creates its own...
It
drives that genetic that process and then recruits those nutrients towards its growth, which depletes those nutrients from its anti-cancer, anti-carcinogenic methylation pathways elsewhere.
Yep, it takes all that material to make its own DNA, RNA, and...
Oh, yeah, it grows its own blood vessels, right? Angiogenesis. It's real tumours are real scary things. And having a gene, an oncogene like a BRCA gene, then just predispose you. It doesn't mean you're going to get it. It's like saying that we're predisposed to prostate cancer because we've got one.
Yeah.
You know what I mean? It doesn't mean we're going to get one. And we're now knowing things that can switch on prostate cancer genes are like dairy is a classic one that drives it up. So if your environment is not, you know, dairy based, then you could avoid that particular expression of that oncogene.
So if I wanted to get this information that we've talked about today and find out how it helps me, the first thing I would do is I'd pretty much go through, I'd get a good understanding of my symptom picture, meaning I'd go back and analyse myself and I'd go, when am I tired? Because it's not good enough to go in to a naturopath like yourself and say, I suffer from fatigue. Because you're going to go back then and spend the next hour going, okay, so do you wake up tired? Is that the worst time of day for you, or do you pick up quite quickly? Do you then crash after lunch? Is it when you're actually exercising, or could you sleep at any moment? You know, so we need to know how's your energy production in general. We need to know how you respond to exercise, and then we're also going to go, so when your body's under stress, how do you manifest?
Yeah.
Do you get the burn? Do you get pain? Or are you more of a sweater or more of a panter? Do you feel sick? Do you feel dizzy? You know, so like we're gonna go through. You need to get a good understanding of your symptom picture. So for anyone out there that's listened to this podcast today, part of it is doing an organic acid test or measuring your organic acids. And with that, you need to gather that bit of information and relate it back to your own symptoms. So we need to know what type of fatigue I get. You know, if you suffer from soreness, when are you sore? Are you sore first thing in the morning, but then it frees up? Or are you the sort of person that's relative, if you do nothing, you're fine?
Yeah.
Then as soon as you start exercising, you immediately go into a soreness. And then when we talk about soreness, we want to say, is it in the muscly tissue or is it in the joints? You know, so what I need people to do for this sort of information is you need to go back and have a really good look at your symptom picture and work out those sort of symptoms. Do I sleep? How do I wake up? Am I refreshed? And sleep requires a lot of energy.
It does. The brain uses more ATP when you sleep and oxygen when you sleep than when you're not sleeping. So
this is the thing. So how you sleep is as equally important for our mapping of your energy production pathways as anything. Then, of course, because you're going to go see a naturopath, and of course, everything you've heard today, of course, we're going to ask about your poo.
Of course,
because if you're like what we're talking about here is a lot of these organic wastes. At this point in time, when we're measuring these wastes in your urine, do we know which ones are from microbiome and which ones are from your body, or are they the same chemicals a lot of the time?
Well, this is the thing, because it gets dumped in the urine, it's metabolic waste products, it doesn't necessarily mean it's just from your gut.
Yeah.
And I guess that's why I like the test, because it's like, you know, sometimes a lot of these things become systemic. So, and the beauty is also that you're measuring metabolites of organisms. You're not actually measuring organisms.
Yeah,
It's like we already said, with a stool test, organisms can die off or they can flourish in transport. So you can have things like Candida grow more while it's being transported to the lab. So those test results can sometimes be very skewed. Whereas when we're measuring on an organic acid test, we're not measuring organisms. So it doesn't matter if they die off or whatever. They doesn't matter where they are in the body. They are producing these metabolites, and that gets transported to the kidneys and dumped into the urine. So you're getting a really good idea of systemic organisms as well.
And is that like, I'm not sure if the language is right here, but would that be like an example of the expression of your microbiome? You know, we talked about the expression of your genes. So one thing to measure to see if you want the microbiome, but you could use the organic acids to see how they are manifesting or how they're behaving, which would be the expression of the microbiome.
Absolutely. Because there's a lot of these, when we're talking about the mitochondria, I mean, Clostridia essentially, Clostridia and Candida hijack the way the TCA or the TCA cycle works, the Krebs cycle.
Citric acid cycle?
Yes. So essentially Clostridia almost cuts that cycle in half because it blocks certain of the pathways within that cycle, and so it cuts it in half. Like you look at Candida, and Candida sort of like upregulates, I think it's the methyl citric acid cycle, I'm not quite sure, but it's like they have their own kind of energy pathways which they then superimpose onto ours and hijack our energy pathways for their own benefit. And so you can see those ratios and those patterns on an organic acid test. So you can see how is Candida, for instance, or what's going on in my gut affecting my cellular energy production, which will then affect how my brain is working and how my liver is detoxing. Because when we're talking about cellular energy, when we talk about energy and fatigue, we think about the adrenals. It's like, no. When we're talking about cellular energy, every single organ in your body needs energy to function. Your pancreas for insulin production, your kidneys for electrolyte regulation, your liver for detoxification. So a lot of people with detox problems, we could even go as far as saying, well, what's the cellular energy of those liver cells looking like?
And in the clinic, and everyone comes in and goes, I feel like I'm falling apart. And they list off these symptoms that cover every part of the body. And that's where you're going, oh no, the good news for you is it's one defect everywhere.
That's
like
right.
You might manifest, depending on what the job of that cell is. For example, your brain doesn't have pain receptors. It doesn't hurt and burn like a muscle would with lactic acid. It manifests with the release of chemicals, which is thinking. So anxiety and worry in the brain is pretty much a brain cramp. It manifests as a sore spastic muscle in another part of the body, but in the lungs, that same process creates a panting. So someone will go, oh, my brain goes, my lungs pant, my muscles go tight, I burn in the gym, I'm falling apart. And you go, no, that's actually one thing. And that's the beauty of it. And what you'll find in that instance is with this Krebs cycle, just so people understand, with the citric acid cycle, the Krebs cycle, people see, they take supplements in their different forms, the alpha-ketoglutarate forms or the fumarate forms and that sort of stuff. So all of these little words and that sort of stuff, they are all the little steps of your Krebs cycle. So when we look at your cellular energy production pathway, when we talk about this Krebs cycle or the citric acid cycle, that's got a whole series of little events that all involve different little amino acids and bits and pieces that get driven into this energy production pathway. Each one of those little steps is stimulated or driven with like a B vitamin or a water-soluble vitamin or something. So we've got vitamins, we have minerals, we have amino acids, all going into a step that's a cycle that produces energy at the end and can also contribute to different metabolic waste. So I got so excited about the organic acid test on the very simple concept that each one of those steps of your energy production pathway can be measured. And then what we can do is create that. If we put that into it's just a big circle. So if we put that back into the circle and say high, high, nothing, 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 high, 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 we can show we can actually go through your energy production pathways, look at these metabolic wastes and go, wow, there is a whole section of energy production you are not doing. Now we can investigate into that. And it's not just about buffering the build-up of the waste. It's working out where we've got excess of something somewhere, we have a deficiency somewhere else, and we can go back and work it out. Then we can go back on, do you have a mitochondrial fatigue problem, or do you have a waste product coming from your guts, or do we have a nutrient deficiency, or do we have just stuck in a stress mode? Or so we can then go back and use all this data in combination with your symptom picture to determine what your particular strengths and weaknesses may be, whether we need to target the microbiome, whether we need to target a particular nutrient deficiency, amino acid or whatever. Very rarely in my experience have I seen that these people are just genuinely protein deficient. In those, I typically ignore the amino acid section because it doesn't really show me a great deal, I don't think.
You mean the last bit? Oh, there's
some
some
cool
interesting
bits in
patterns.
there.
Yeah.
We did a podcast on the tryptophan steel.
Yeah.
Just so you know about that. So
Yes,
I mean, we talked about how when that can drive anxiety and that sort of stuff, and that's one amino acid that we focus a lot on there.
Yeah, absolutely.
But there's a few others there. Do you want to highlight some of your
tell us some
favourites
cool
you like?
Yeah, like I mean in the amino acids specifically. So one of the ones that I think is very underrated,
yes,
and which because I see so many of them, is I think it's the 2-hydroxyisocaproic acid, if I remember correctly, or it could be the 3-methyl-2-oxavaleric acid. But they are very much when they come up abnormal, which is not very often, but I've seen it quite a few times, that's usually an indication of vitamin B1 deficiency, which is more in the TPP form, which is your thiamine pyrophosphate. So it's like an active form of B1 or a coenzymated B1 if you want. And that one becomes, when that one becomes depleted, you'll start to dump B5 in the urine. And B5 is needed for acetyl-CoA production, adrenal hormones, sex hormones,
all
blah,
your
blah, blah.
goodies.
And also it becomes B1 gets depleted very commonly with Candida because Candida produces acetyl aldehydes.
Yes.
So even like just people with a lot of sensitivities to perfumes and chemicals, paint fumes and stuff like that, it means that acetyl aldehyde dehydrogenase enzyme is not working as well, most likely because it doesn't have the cofactors, which is B1, to function well. And so a lot of people with a lot of chemical sensitivities and Candida overgrowth have this B1 deficiency.
Just on that too, this is the classic one from medically for those who may not. There's, if you drink a lot of alcohol, you get a condition of thiamine deficiency. And this is called Korsakoff syndrome, where you simply brain doesn't work. Now this is probably they're probably not at that level yet,
no.
but it's a very, very starting effect to this particular thing, and thiamine is hugely important to the brain.
And we
so they just get brain fogged. And they go, don't know, and it's just people lose track of what they're up to. They forget what they said a few minutes ago, and that's classic Korsakoff. If you ever interview Korsakoff patients, they make up stories. They're not lying, but they're making up stories based on what they see right then because they believe that as a memory. That's how important thiamine is.
So things like dementia and all that sort of stuff would be linked in with that as well?
Absolutely. Because we always focus on B12 and folate and B6. And we sort of like forget about some of the other ones and how important they are. And I actually see a lot of deficiencies in that.
I remember the old days. I remember back in the 90s.
Black and white days.
No, I remember back in the 90s and that sort of stuff. There was a lot of it was about the sympathetic nervous system dominance, but supporting the parasympathetic nervous system, supporting acetylcholine production. A lot of it was B1 and B5. Big mega doses of B1 and B5. It seems to have gone a little bit out off the radar. Yeah,
but if you use the TPP form, you don't need as much. Like if you're using plain thiamine or B1 that you just get off the shelf, you can often need, and I'm not telling people to take these doses, obviously you'd have to always work with your practitioner.
Oh, well done.
But often, we can use up to 500 milligrams. But when you're working with TPP, the coenzymated B1, it's like 10 milligrams. You need only a tiny amount of that. That's
interesting, eh?
It is. So it's the activated form. I think injections that Beck gives in the hospital for some of these would be about a gram. Of thiamine, mega doses just to overcome.
Well, I remember in the old acetylcholine, we used to talk about a symptom picture of poor short-term memory, concentration span, poor close vision, dry mouth, hot burning feet syndrome, poor digestion, poor sleep, and all those manifest of those. And he definitely poor short-term memory, focus, concentration span, and ability to remember what you just read. And, but other weird shit like the dry mouth and the burning feet, some bizarre thing. And we used to do the 250 milligrams of B1, 500 milligrams of B5.
Huge
and
B5.
That's how we do it to fix it. And we'd usually stack it with an acetylcholine esterase inhibitor, you know, like a ginkgo or something, to preserve that acetylcholine and make a quick flip. Because we knew we could never drop the sympathetic nervous system because everyone was so stressed. So we used to try to build up we used to build up the B1s and B5 and build up all this acetylcholine. But yeah, it's so much more complicated when you go back and individually work out why the hell that person's got the problem.
And
very rarely is it just nutrients.
Exactly. And even medically today, the number one treatment for Alzheimer's is acetylcholinesterase inhibitor drugs. That's how far they've got. They know acetylcholine levels are low, and that's result for making memories. And this is medically where they're at. So to get back to this B1 and the TPP level of B1 and these sorts of things is terrific. And you can pick it up early on this too.
Yeah, absolutely.
That's what I love it.
And the beauty is that it changes very quickly as well. I mean, I've seen some, incredibly high markers in these tests. But if you treat it correctly, within a 4-month period, you'd retest and they're all normal. So it doesn't take years of detoxification or whatever. And like I said, you don't treat every single marker also, because I've seen a lot of, especially the nutrient markers. So a lot of time the nutrient markers come back wacky.
And vitamin C.
Vitamin C, but also all the B vitamins and things like that. And I've often treated people without giving them a single nutrient. I've identified what's the core issue, the root cause. You treat that, and the nutrients come back on its own. The nutrients normalize on its own without taking a multivitamin or anything like that. So if you treat the right things, you get the body a chance to heal and to regulate itself and absorb nutrients and all of those things.
So awesome. Now I want to pick your brains a little bit, ask you a question without notice. I want to know what your opinion is on folic acid and folic acid fortification foods and the overabundance of folic acid in our lifestyles. It's prescribed again medically compared to the natural folates.
So your natural folates that you get from your green leafy vegetables and eggs and stuff is obviously a much healthier form. I've never been a fan of fortification. For me, that's mass medication, and you can't control how much people eat. So they'll say, oh, well, if you eat 2 slices of bread a day, you'll get your daily requirements of folic acid in. And it's like, well, there are people who eat a whole loaf of bread a day. So you can't control people's intake. So it's mass medication. Now, folic acid in itself, it uses up a lot of the DHFR enzyme, I think, if I remember correctly. So it just
dihydrofolate reductase for those who want to know.
That's the one. So it has to. I think it uses about twice as much of that enzyme function, which just means it's slower to go through the methylation cycle. So I'm not a big fan of the artificial folic acid, but unfortunately that's what they put in most multivitamins unless you buy like an activated form. But in the end of the day, you want to get it from your food because you get methylfolate from your food, from your vegetables and from your eggs. So never been a fan of synthetic vitamins or fortification in general.
And that was one of the things, I was going to say it in the intro and I forgot. But one of the things when I first saw Elizma speak, I was about to call you Elizma again. First time I saw Elizma speak, I stopped myself from giving her standing ovation over one line because she said to a doctor in the crowd, they were asking these sort of questions, and then just actually said, but please don't forget you need to fortify your prescriptions with food. So you've just talked about that. We've gone through this phase where we used to eat food for nutrients, and we all knew that food had nutrients, which is why we ate them. Even the stuff that tasted bad, we'd eat it because we knew it was good for us. Into a phase where we were convinced that nature's idiots, we're smarter, we're going to go through these high-end prescriptions, and I'm talking mega dosing, some of these FIFA protocols, and they're insane. And so what happens is that the medical world got involved in the supplementation, and that more is better, smacking these things through. And Elizma's there reminding the doctors to fortify their prescriptions with food as opposed to fortifying food with nutrients. You had to remind them that, fortify your nutrient prescriptions with food again to get them back online.
That's right.
Oh, that was so cool.
It's funny because you're right. I mean, it's terrible that they're mass medicating. I use that word. I'm controversially, I'm against fluoride, in water because
it's the same
that's just
thing.
saying, well, I just drank that much fluoride just then, and and someone might not, and someone who works on a building site might drink 6 litres of fluoride a day, and fluoride's potentially toxic. I mean, this is scary. Even if you think it's good for your teeth, let's assume it is. Most people swallow the water.
Yeah, I think the studies I saw on fluoride was that if you apply it topically, it has a beneficial effect, but swallowing has a detrimental effect.
Very much so.
Yeah.
And it's like you said, everyone swallows their toothpaste.
There's no biochemical pathway
I even
for
swallow
fluoride.
my water.
No,
it's true.
You don't.
Spit it out.
I inhale.
I just rinse it around and spit it across the room.
You're
or
a
in a spit
connoisseur.
bucket. Yeah, you see the spit bucket in your mouth.
I think it's good to get your fluoride on your teeth that way.
Exactly.
Was it Ceylon tea or one of those was the worst too? So
they're
that was
very
with the
hard.
fluoride. The teeth are the little old ladies with that don't need. They've got no bloody teeth. I'm only talking about the ones with no teeth, so don't be offended if you're one with teeth. They got their little teapots with their thing that they're sipping on all day. They're using their tap water because they're not paying the big bucks for the flash water. And they're loading up with that. And this is when they get the skeletal fluorosis and that sort of stuff. So. And
screws of the
maybe
pineal
dementia
glands.
even.
I think osteosarcomas are also linked to fluoride.
Which is a type of bone cancer.
Yeah, fun, huh?
Yeah, it's good. Also, pituitary, sleep problems and all that sort of stuff. I'm glad you said that because I didn't, we're not fans of folic acid here. We're fans of natural folates. And I didn't even tell you about that, but I'm so glad you said that because...
Lucky,
Lucky.
Edit that whole section.
We would have gone...
we're not going to get this back on
Give everyone Megafol because you've got to remember Megafol's a standard prescription for anyone wanting to fall pregnant. And it's really quite scary because they don't give... they give 5 milligrams.
Tongue tie.
Yeah, it's huge amounts of folic acid.
Because they figure
5
that
milligrams.
if you're 1 in 10 that struggle to convert it, we just give you more.
Yeah, and what it does is I think it binds to FOLR3 receptors.
It does.
So it still has an effect, and then they've linked that effect of the unmetabolized folic acid through to tongue tie, childhood leukemia, behavioural disorders, speech aplexias, all that sort of stuff. So
really
anyway,
stuff.
I think we covered a heap of stuff. We're going to get you back, and we're going to do this all the time now because I've got a big plan. We're going to do the calcium. We've got to talk about calcium influx more.
Definitely.
We've got to talk
Calcium
about
dysregulation.
genetic expression versus genetic profiling to screen us all.
Thanks for everything today. This has been...
It's good fun.
It's been fantastic. Thanks for that.
No, it was a lot of fun.
It's been
Good
joyous.
brain stimulation, that's for sure.
Yeah, no, it's been great.
These two, a little bit of chemistry. No. Biochemistry.
Take the marriage ring off.
Oh, you're stuff.
No, I can't take that off.
No, you can't. It's got to contribute
fell off when I was
15%
swimming.
increase of heart disease by wearing that ring.
Exactly.
Really?
Yeah, that was an interesting study.
Yeah, real interesting. I just got married too when I found that study out. I'm thinking,
Congratulations.
it's been a year now, so but I love you, Becky, because she watches.
Look, it's
So
all gone really awkward to Steve here, eh? I just mentioned the chemistry other than biochemistry, and he's like panicked.
Oh, panicked. Oh, goodness me.
Right.
Well, it's about time to wrap this up, isn't it? Quick. Well, look, it's been great. It's been fun today.
Cool.
Love the biochemistry.
Well, thanks for having us. I mean, I said thanks for coming in.
Thanks, guys. See ya.
All right.